Hello and welcome. In this video, I'm going to talk about the new CashScript pre-release and what new features this adds to CashScript. So let's take a look. I'm on the next.cashscript.org, the documentation for these pre-releases, and we'll take a look at the release notes. Also make myself a bit smaller so we can see what's going on. This update adds support for the new BCH 2025 network upgrade. To read more about the upgrade, see this blog post. So the BCH 2025 network upgrade, as you might know, it retargets the VM limits and it also adds big integer support to Bitcoin Cash. So the first two items are related to this network upgrade. We remove the warning for the op count and update the warning for the byte size to match the new VM limits. And also in the SDK, with the debugging tooling, we use the new 2025 instruction set. And this is referring to the fact that with big integers, some of the arithmetic opcodes like addition and multiplication, they have different behavior because before they used to fail when a number was bigger than 64-bit integer, but now this overflow behavior doesn't happen. So these large multiplications are simply allowed, and this is these are essentially updates to the workings of the opcodes. So now CashScript uses the updated instruction set for the upcoming network upgrade. And now we get to this CashScript specific new features and what I'm very excited about. Namely, add debugging capabilities to the transaction builder class. And this consists of three items. You can now do transaction.debug and transaction.toBit.uri for this transaction builder. There is now an output for a bit.ide URI for debugging when a transaction is rejected. So if something goes wrong, you immediately get a link for debugging. And libal template generation and debugging now work for multi-contract transactions. So this is the very big item because before, if you had complex transactions using multiple smart contract inputs, there was no debugging tooling at all. So it was very hard to figure out why transactions were failing or what was wrong with your setup. But now all the debugging tooling just works with multi-contract transactions when using the transaction builder. So this is very exciting. And makes it so all use cases are supported with the transaction builder class. And this is also why we have this next item, deprecate the simple transaction builder. You can still use the simple transaction builder with the current SDK, but the support will be removed in a future release. So it doesn't make sense to have two ways of doing the same thing when one supports the advanced use cases like multi-contract transactions. So you only have to learn one thing and it supports everything well. Whereas before there were two transaction builders, which is kind of confusing. And then lastly, you have a breaking change, remove support for old contracts compiled with CashScript version 0.6 or earlier. So 0.6 is many years ago at this point. So if you still have a contract from before version 0.6, just compile it with one of the newer versions and you'll still be able to use it. But this is a breaking change. So one thing about the transaction builder is that in the docs, you now have just the transaction builder and it will have the docs about the transaction builder with a note for the documentation about the old and deprecated transaction builder API referred to this documentation page instead. Whereas with the current CashScript version, if you get started, then you have here simple transaction builder, advanced transaction builder. So it's already confusing why you have two transaction builders. So this simple one, which is actually just a limited one because it cannot combine multi-contracts, has been deprecated. And now if you refer to it, it will say old transaction builder. This documentation is for the old and deprecated simple transaction builder, which works by calling a function on the contract object directly. It is strongly recommended to migrate over to the new default transaction builder using the migration nodes. So we'll actually take a look at this in a bit, but for now, I think it's better to navigate to the debugging guide because we have put a lot of effort into updating this also. So it talks now about the two categories of bugs. There can be a bug in your transaction building or a bug in your contract logic. Note that there is no, it's all unified. So you can use this debugging tooling, all of it with the one transaction builder because it now supports the debugging capabilities. So you will have these nice error messages which say which statement failed in which input, which contract, and then it will even provide the failing statement. You can use console logging, and you can use the bit.ly IDE for low-level debugging. So if you click a link for the bit.ly IDE, as we talked about in other videos, you will see here the opcodes on the left-hand side, with on the right-hand side the CashScript code. And then you can easily see what is going on both on the low level and on the high level. So this is also just very good for understanding, but it's especially useful for debugging complex cases. And we also added this note. It says currently the raw BCH script you see in the bit.ly IDE, so here on the left-hand side, is what the script looks like before any optimizations happened to the compiled output. This means you might spot some inefficiencies, but those will likely not be present in the final compiled output. So even, for example, if you see that multiple opcodes could be somehow combined or simplified, optimized, these optimizations likely happen, but it's just not what you see in the bit.ly IDE. So this is one note and something we'll try to improve in the future. Also, another thing I want to mention is these changes are not everything that is planned for the version 0.11 upgrade. When you go to CashScript, I'm already on the milestones, but if you look at issues, you will see the whole list of issues, what we plan to work on with CashScript, and you also have the milestones. And milestones allow us to batch different issues for a release. So for example, we are currently working on the version 0.11 upgrade and these pre-releases, of course. So if you click on this, you can see which other items we still plan to do before we do the proper version 0.11 release. And this includes updating the Electrum cache library and also renaming transaction.h. So these will be two planned breaking changes still, and a bunch of other optimizations. So if you're curious, I highly recommend taking a look at the milestones on GitHub, and you can even get involved if you have a comment on any of these items. So yeah, that's what we're planning for the other releases of version 0.11. I also want to talk about the migration node. So if you're interested in using the new transaction builder already with the unified debugging capabilities, then you can take a look at the migration nodes, and it says the simple transaction builder has been marked as deprecated, and the advanced transaction builder is now simply referred to as the CashScript transaction builder, as there is only one supported for the future. An example: since the new transaction builder is quite different from the old one, it may be useful to see an example refactored from the old way to the new way. So here we see the old transaction builder in action, and the transaction builder works by calling a function on a contract. So you see contract.functions, and then it calls the transfer function on the transfer with timeout contract. So you can clearly see that this doesn't allow for multi-contract inputs, because you call the abstraction that this transaction builder provides is calling a function on a contract. So it doesn't even allow for multiple instances of the same contract. And then you have these additions to be more specific. For example, if you want to specify which UTXOs are used, then you have to provide this, because otherwise it uses automatic UTXO selection. Then you have this different syntax for adding a pay to public key hash input. Here we add an output, and then you have to explicitly say without change if you don't want the automatic behavior. Whereas with the new transaction builder, everything is explicit. You explicitly define the in and outputs. So you here have, we import the transaction builder, then we say new transaction builder with the provider, and the provider is currently initialized on mainnet. And then we add an input, namely the selected contract UTXO. We add an input for Bob, so from Bob UTXOs, and then we also have to provide an unlocker. So in this case, the unlocker is contract.unlock.transfer. So you can see the transfer, of course, is in both transaction builders, but here the whole transaction is being built on this transfer function, whereas here it's just providing an unlocker to one input. So you can clearly see that using this syntax, you could add another input with a different smart contract. So it allows for multi-contract transactions in a simple way by having just these unlockers, and it plays much nicer with the UTXO transaction model because you add inputs and outputs explicitly, whereas here you kind of call a function on a contract, which is which is an abstraction that doesn't play too well with the UTXO model. And then you don't have to say without change, because everything is explicit. So let's read this at the bottom. With the new transaction builder, all inputs and outputs are explicitly specified. This means that there are no automatic change outputs added for BCH or for tokens. This means also that there's no with minimum change, without change, with token change, with hard-coded fee, and with fee per byte methods. The developer is responsible for manually adding change outputs. There's still the option to use .setMaxFee as a security measure to prevent transactions from being too expensive. So now we really went over in detail how the two transaction builders differ, how this one is more explicit and more flexible, and also simply easier. So if we take a quick look at the SDK again, so the transaction builder, we have add inputs, add outputs, and also the multiple add outputs, an op return output, set log time, and then lastly set max fee. So a handful, but you will mainly use add input and add output. But then if you take a look at the old way of doing things, which is also linked at the top, then here you have a bunch of other things. You have .from pay to public key hash, and then all these utilities to handle fees and change output. So it's actually just much more complex. So as we talked about, you have this migration guide if you want to migrate over, and it's mainly helpful if you want to use debugging for multi-contract transactions. So that's the key new innovation added with this release, that you can now use debugging for multi-contract transactions. We also updated a bunch of other things in the documentation. So if you want to, for example, use the testing setup here in the TypeScript SDK testing setup, then we improved this documentation to all use the new transaction builder. For example, here you have a full example at the bottom. We import the testing setup, and then here we provide the transaction builder. And we have a few test cases. For example, it should log a parameter. Then we can just write a test here like you would do in JavaScript. Expect the transaction to log. Past parameter is 1000. Here we have a test which expects failure. And then at the bottom you see expect transaction to fail require width. Past parameter is not 1000. Yeah, because we pass 999 here. And then lastly, should pass require statement when correct parameter is passed. So here we pass 1000. And we see expect transaction not to fail require. So this is how you can make a testing framework using the transaction builder, and also using the mock network environment. So this is really a feature of CashScript that makes contract development much safer, because you can use a virtual mock network environment to write these tests and add, here you see the contract that was used, but so you can add failure cases, check for logs, check for valid spending conditions, so you can have much more confidence in your code. And that's of course what we want for smart contract development. So that's everything I have to showcase for this pre-release of CashScript. I hope you are excited to try it out, and I will see you in the next video. Bye bye.